Hello, Beth. Can you
Hello.
hear it?
I can. Can
Hello.
you hear me? Perfect.
So for the attendees then that are listening in English, Elisabeth Guertal is a Ph.D. as a professor at Orange University. She earned her bachelor and master degree from the Ohio State University and her Ph.D. from Oklahoma State University. Guertal's research interests and areas of focus include soil fertility, turfgrass management, and the flux of fertilizers nutrients in the turfgrass environment. Guertal's excellence in the turf industry has been well documented through numerous awards she has received, including Outstanding Instructor in the Department of Agronomy and Soils at Auburn University, the Novartis Award in Agronomy for Outstanding Achievement in Teaching and Research from the American Society of Agronomy, and a Fulbright Fellowship from the University of Mauritius. In addition to her university responsibilities, Guertal has served as elected chair for Division C5, the Crop Science Society of America, and as a technical and associate editor for the journal Crop Science. She is a fellow of the Crop Science Society, the Soil Science Society, and the American Society of Agronomy. A lot of societies, Guertal. Guertal has been a golf course superintendent American Association faculty member since 2001, teaching at the Education Conference, as well as numerous webcasts, like today, that is presenting a webinar for the campus of Césped. So for me, that's all. So it's your time
Okay.
whenever you're done.
Great. Well,
Thank you very much.
thank you. And I understand that it is evening for most of you, so buenos tardes. And today we are going to talk about soil fertilization, and we've kind of separated it up into, whoops, hang on, let me get my screen to advance. There we go. So we have separated it into some of the myths and the legends, what things are facts, or what sort of beliefs might we have, things that we have long believed about turfgrass management that isn't true. One of the facts about turfgrass that we all know is that to grow a warm season grass, particularly like Bermuda grass and some cool season grasses, they need nitrogen. And one of the things that we have seen a lot lately in turfgrass management is this idea of greatly reduced rates of nitrogen. But the research that we do at Auburn shows that you do need some bare minimum level of nitrogen to grow grass. And when you don't have enough, you see the sort of things like here, where I'm drawing this circle, and what we have there is dollar spot. And that dollar spot, sclerotinia, has come in on the Bermuda grass because that is an unfertilized area of the Bermuda. And a lot of research that we do with Bermuda grass is simply based on the color or quality or shoot density of the Bermuda grass as affected by nitrogen. Because one of the facts about nitrogen is that we do not have a calibrated soil test for nitrogen. Nowhere in the world can I go out and take a soil test and from that analysis of the soil come back to you as a superintendent and say to you, you need to apply this much nitrogen fertilizer because your soil test says so. This is because nitrogen is really affected by lots of different microorganisms and living matter and soil moisture and soil temperature. So it's very hard to come up with a calibrated soil test. Notice here, I'm not talking about nitrogen, I'm talking about potassium, because we do have a soil test for potassium, and this is an example of when I say calibration. So this down here would be soil test potassium. from very, very little, 0, to very, very high, lots of potassium. Here is whatever you are measuring. Maybe it's color, maybe it's ball roll, maybe it's shoot density. And what we say is when there's not very much soil potassium and you add more by fertilization, your color improves, or you get higher shoot density, or your ball rolls faster, or you have less disease to some point. And after this point, no matter how much soil test K you have, you see no response. See how that line is flat? These are what we call calibrations, but we don't have any of this for nitrogen because nitrogen changes so rapidly in the soil. Now, it's coming. In the next 5 to 10 years, we are going to have some ways that we can predict nitrogen fertilization based on some kind of test. It probably will never be a soil test, but we're going to have things like remote sensing. So this is an application for your cell phone. You download it, and this is a little color chip that you throw onto your turf grass. So this is the calibration. So the greenness of your turf is being compared to the green and to the yellow and to the white. The idea would be eventually you would go out, take pictures of your turf, and the program would say to you, you know, we need to add a little nitrogen here. The plant will respond. The color is showing me we need to add nitrogen. But we're not there yet. And I know there's a lot of interest in flying drones across fairways and taking pictures. But the problem is that this sort of thing is still very dependent on cultivar. Which grass are you growing? It changes. Something as simple as mowing height can affect the values. But we are getting there. So we tend to base our nitrogen on the crop response. And that is where you are the experts because you know how your grasses respond to nitrogen. So we put out the nitrogen and you as a superintendent say, that looks pretty good. I don't need to add any more. But this is changing. If you remove your clippings, you take away the clippings, such as on a putting green, you need to add a little more nitrogen. If you have very sandy soils, soils that have a lot of sand and that are irrigated regularly, you will lose more nitrogen. But if you have, say, an out-of-the-way area or a rough where the golfers don't go and there's no traffic and you just don't mow very often, you can use less nitrogen. Now, one of the things we will talk about briefly, if any of you manage zoysia grass, and I'm not sure if you do, perhaps someone could put a note in the chat whether or not you do have zoysia grass. It doesn't tend to respond to nitrogen. Our work that we've been doing here at Auburn is showing that if you get above, if you apply more than 10 grams of nitrogen per square meter per year, it can actually begin to harm the zoysia grass. Zoysia grass and centipede grass don't tend to respond to excessive nitrogen the way grasses like Bermuda grass will. perennial rye is a little more responsive to nitrogen than, for example, tall fescue. But the fact is, we apply all these nitrogen rates right now based on crop response. Now, here's another myth we hear a lot. In turfgrass management right now, there is a lot of interest in organic products, adding materials that are high in carbon to the soil, or adding fertilizers that have lots of different bacteria formations in them. One of the more popular I'm seeing are different types of bacillus. So what people say is you will see a very rapid response and microbial activity, and you will quickly grow your soil carbon. And when we look at the research, that tends to not be true. What do I mean when I say quickly? I mean within 1 to 2 years. So here we have an experiment on tiff green Bermuda grass. So this was done down in Florida on Bermuda grass. And what Dr. Elliott did was she fertilized with 1, 2, 3, 4, 5 different types of fertilizer. These are all organic. So milorganite is from sewage sludge, the waste material of people. This is a byproduct, I can't remember, no say. This one is from processing animal waste, and this one is the waste material of turkeys. So all of these are some type of a manure or a waste. And again, they're often marketed as rapidly increasing your microbial populations and the microbial pool. IBDU, isobutylene diurea. That is a slow release fertilizer that contains carbon. So the point here is that all of these materials contain carbon. And carbon is what the microbial pool wants to feed upon. That is the food source. They don't care if the carbon comes from IBDU or I'm sorry, lo siento. If it comes from turkey litter or stockyard waste or human poop, it's all the same. So what she did was she measured the total populations of bacillus, the fungi, actinomyces, and total bacteria. What you see is that there was no difference due to end source in any of these things measured. So after 2 years of fertilizing with these different carbon-based fertilizers, the microbial pool was unaffected. So most of our research shows this, that short-term effects from microbial products don't tend to happen. But long-term application does affect the microbial pool. So here we have a different study. They used Kentucky bluegrass, and for 15 years they put out these different treatments. The treatments, pardon, the treatments were organic fertilization, So that was a waste product taken from stockyard, the processing of animals for food. Everything that isn't used is often used as an organic fertilizer. Then they had urea, and then they had an inorganic fertilizer. Now, remember, I said microbial biomass, it's using carbon as its food source to grow. Guess what? Urea contains carbon. Urea has carbon. So it is considered to be a synthetic organic fertilizer. So when someone wants to talk to you about organic fertilizers, they really don't mean urea, but the real truth is it has carbon. Inorganic means it doesn't have carbon. There is no carbon. This would be something like ammonium sulfate or ammonium nitrate or calcium nitrate or potassium nitrate. None of those contain carbon. So they put these three fertilizers, a true organic from a waste product, urea, and an inorganic, out at 1, 2, 3 different rates for 15 years. And what did they find? Now, these numbers here are what we call a p-value. They're simply a statistical test. So if the number is very, very small, that is telling you that it is significant. So if I were to repeat this experiment 100 times, here we're saying that 99.999% of the time, microbial biomass, the microbes in the soil, are affected by the fertilizer source. Is it control, organic, or inorganic fertilizer? Notice in this study, they also looked at things like herbicides versus none, insecticides versus none, and fungicides versus none. Because all of these numbers are big, any number that is bigger than that 0.1, it had no effect. So for instance, they counted nematodes. Fertilizer type did not affect the population of nematodes. That's total nematodes. Fertilizer type did not affect plant parasitic nematodes. And that's interesting because there are people who will tell you that certain organic fertilizers reduce nematodes, and there's really not much evidence of that. So out of all of this, the only two things that were affected over 15 years of application was microbial biomass nitrogen and organic matter content. So if we look at this closer, here we have, there it goes, the highest rate of organic nitrogen, and this is how much was applied in total of the organic. Here is the inorganic, no carbon in that, so that was actually ammonium nitrate fertilizer, okay? Notice the only significant effect was this, microbial biomass and organic matter. So 15 years of it using an organic product did increase it. So it is a fact that in the long term, if you use these organic materials, we do see increases. But the short term, 1 to 2 years, it's not evident. So it takes a while to see this increase, but it does happen. Now, over the long term, this is our own, we are now in the 11th year of this study, and you see we're putting out nitrogen on this Bermuda grass at various rates. And here, for example, is 10 grams of nitrogen per square meter per year. Here is, I think, 2 grams. It's not enough. And here is our check plot. So this has no nitrogen. And over 10 years, you see here's another check plot. Isn't that, it's kind of cool, really. And then here's another check plot right there. And what's, excuse me, and what's happened here is that, there we go, is that this system has become so deprived of nitrogen that the white clover has come in. White clover, of course, is a legume, Leguminosae, and it fixes nitrogen. So it's taken advantage of the late season, or the no nitrogen, and is doing quite well. Well, let's go to a different type of myth. One of the things that we often hear in the United States is that late season application to Bermuda grass can cause winter kill. And it's one of those things where nobody really looked at it closely. And so when you look at all the data, you have the same types of rate from 4.9 to 9.8 grams of nitrogen per square meter. So in English units, that's 1 to 2 pounds of nitrogen per 1,000 square feet. What they did at Mississippi was they put it out in the middle of October. Here they put it at the end of September, also in Mississippi. Here in Arkansas, June 15th, August 15th, and September 15th. And then here it was up in Kentucky on August 15th. So in our southeastern United States conditions, we would have been telling superintendents, particularly in September and October, no more nitrogen. Don't put that nitrogen on your Bermuda grass because you could give the Bermuda grass winter kill. In every single one of these studies, there was no negative problem. It never killed the Bermuda grass. It did not hurt the grass. The grass, in fact, in this study, which was done with tiff green Bermuda grass, 328 is the other name for the tiff green, it kept better fall color and it greened up earlier in the spring. The same thing here in Arkansas on Tiffway 419. It too retained fall color. It stayed greener longer and it did better the following spring. So this idea, if your Bermuda grass has not yet gone into dormancy and you think you may have a month or so before it does, we are seeing benefits with some late season nitrogen because it keeps the grass greener longer and it greens up earlier in the spring. Now, that does not mean to put it out there when your turf is dormant. There has been some discussion lately on the internet about fertilizing dormant zoysia grass some weird thing about it fertilizes, I'm not sure, the root fungi. And I'm here to say, do not do that. If your grass is dormant, the nitrogen can leach. It can move downward to your groundwater out of the rooting zone. Now, this graph is bent grass, but what you see is the bent grass went out at very low rates weekly as a foliar spray. But here you see a peak, and then here you see a peak. Notice the date. This is August, and here is August again. In the humid heat of an Alabama summer, the roots on that bent grass are very, very short, and it doesn't have the ability to use the nitrogen. So you see this repeating loss of nitrate nitrogen out of the rooting zone because the bent grass doesn't need it. So in the same way, when your Bermuda grass is dormant in the cold weather, it doesn't need dormant fertilization. Now, this is a fact as well. Extra nitrogen does not make your grass grow faster. And I know you know this because you are turf grass experts. But sometimes you might be doing a new grow-in, or you're helping with a local football field, and somebody says, oh, let's put more nitrogen on. It will help it grow faster. But what it does is the nitrogen simply goes into the leaves. It doesn't go into the stolons and rhizomes or the roots. All you do is produce a lot of leaf material, and then when you go to mow it, it scalps. So here's an example of the kinds of measurements we take. Now, this is more for an athletic field. This is a meter, and at the top here, it tells us how much slip, or if you put your foot in the turf, would you slip as you turned your foot? At the bottom are football cleats. So we have these individual football cleats. So we actually set this device up on the turf like that, and the cleats are down here. And then we turn it to get an idea of slip. So what you see here on the graph is this is not very slippery, and as this number goes down, you get more slip. So as your nitrogen rates increase from recommended to way too much nitrogen, the turf gets more slippery. So in other words, if you put your foot in this turf and tried to turn, you would have better traction here and less traction down here. Why? All that extra nitrogen goes into leaf growth. And if it's going into leaf growth, you often are not growing roots. So here again is kind of this is per week, because we were establishing Tiff-Eagle Bermuda grass. But again, high rates of nitrogen decrease root growth. And they decrease the dry weight of the stolons and the rhizomes. We care about this because the stolons and the rhizomes are the stems. They are the energy reserves by which the plant grows. So those are so here is your ground, and rhizomes are the below ground things from which all the shoots come. And hang on here. Stolons are the above ground from which all the shoots come. Now, seashore paspalum, Bermuda grass, and zoysia all have rhizomes and stolons. So what you see as you add more nitrogen from recommended to way too much, the dry weight of your stolons and rhizomes decreases. So what you end up with is a very lush grass with lots of leaves that doesn't heal well from damage. And last is carbohydrates. Carbohydrates are the energy reserves for the plant. So again, when you over apply nitrogen, there it is. When you over apply nitrogen, carbohydrate content goes down. And what this can affect is the ability of your warm season grasses to green up and recover and grow in the spring. Now, another thing we talk about is the environmental aspect of fertilizers. Nitrate will leach. It will move down into groundwater, and it will move out of your rooting zone. This is a study that was done with Kentucky bluegrass for years and years at Michigan State University, and it's still going on. So it is now up to 2016. So for the first years of the study, this high N rate was 5 pounds of N per thousand, so 25 grams of nitrogen per square meter. That is a lot of nitrogen for Kentucky bluegrass. This low N rate was 10 grams of nitrogen per square meter. So what you see, this is a non-recommended, non-agronomic rate. And look at how much nitrogen leached or was lost. That is environmentally bad. But right here in 2003, they said, we know it's too high. No one should do that. So we're going to reduce it to 20 grams of nitrogen per square meter. So they went from 5 pounds to 4 using English units. Look at how the loss has started to decline. And when I talked to the person who runs this study, he said, since this data up to here, the lines almost lay on top of each other. So it is a fact that nitrate will leach, but when we work at correct rates, like my data here, when we apply nitrogen correctly, it is not an environmental risk. Here, everything was applied at 4.9 grams of N per square meter to Bermuda grass. That is a recommended rate. And yes, using a slow release source like a polymer-coated nitrogen had less nitrate leaching than pure urea. But the point to be made is it's all environmentally safe. You see this number here of 7. Well, the United States EPA standard is 10. The point where we worry about nitrate leaching to groundwater is 10 parts per million or micrograms per milliliter. So when you apply your nitrogen at the correct rate and safely, turfgrass does a very nice job of filtering nutrients. Now, phosphorus. Phosphorus can move with runoff. So this says overland flow. The simple word for that is runoff. And what you see here is a bare, eroded soil, and it is moved, and you notice how all the fine soil, the clay, is here. And they put this silt fence in, but here it has collapsed. It's no longer working. So that soil, the clay, with the phosphorus attached to it, is going to come over that and come right down here to this stream. And that is a pollution problem. So phosphorus, it is a fact, we worry about it a little bit with runoff. But you know how you stop it? You put vegetation here. Again, turf grass, established turf grass, is the first choice to slow and stop runoff. We do not have to worry about phosphorus leaching or moving downward to your drain lines. Here you see work. This is 3 months, and here is 6 months. See, you don't see curves that are doing this. We aren't seeing phosphorus leaching. Phosphorus accumulates in the soil profile. So if you're worried about your phosphorus soil tests, you just need to sample the top 6 centimeters or so, because that is where your phosphorus accumulates. So here is a very sandy soil at one location, and we see it the same thing at a soil that has a little more clay in it at a second location. We do not worry too much about phosphorus leaching. Actually, this is the sandy soil. Let me correct myself. The second one is the sand. The honest truth is that most of our phosphorus soil tests are too high. If you look at these numbers, you notice that somewhere around 20 milligrams per kilogram of extractable soil phosphorus is probably more than enough for your grasses. Particularly if you are trying to have lower values of phosphorus. Lower values of annual bluegrass. Annual bluegrass really likes phosphorus. Here we have an annual bluegrass plant with no phosphorus, and as the phosphorus increases, look at how much bigger the plant gets. So here in the southeast United States, we don't like annual bluegrass. In warm season systems, we want it gone. So you notice as phosphorus, where'd it go? There it is. As phosphorus increases, you have more seed. The weight of all seed increases. With no phosphorus, it was 203 grams. With way too much phosphorus, it was 365. And also, the seeds appeared earlier. So when there was no phosphorus, it was 127 days until we saw the first seed head. When there was too much phosphorus, those first seed heads appeared 10 days earlier. So one key to managing annual bluegrass is to keep soil test phosphorus low. Now, I have 5 minutes. Let's talk quickly about potassium. A legend is that we apply potassium when there's stress, when there's cold, when there's drought, when there's traffic. In fact, you notice in many areas it's marketed that way. This label says a winterizer lawn fertilizer, and it's very high in potassium. The truth of this is that there's very little relationship. We just do not see in our research, especially with Bermuda grass. We have 3 to 4 different studies with Tifway and Tif Green and Tif Dwarf that do not see that adding lots of extra potassium stops winter kill or damage to Bermuda grass. Right now, it is pretty much a myth. And you look here at the rates, 2 pounds, 9.3 grams, we simply don't see any effect. So potassium is another unit, another nutrient that you might be able to not apply as much and be fine. Now, let me say there is some new research showing that potassium has some benefits on fusarium and some other diseases. On cool season grasses in the Northeast United States, they're seeing some benefits, but that is very new data at this point. So, extra potassium from warm season grasses like Bermuda grass is not necessary. It is a myth. In cool season grasses, maybe, but it only seems to help if we have a problem with nitrogen. So make sure there's plenty of nitrogen, and then maybe the potassium helps. But in all honesty, we don't tend to see a lot of benefits for adding potassium in stress. Okay, let me scoot through. I was afraid we'd have too many slides. Okay. Woo, I got a lot. All right. We'll have to do another one, Xavier, to catch up on all this. There. All right. So, moving to the very end of potassium, the honest truth is that when you look at all the studies that have been done in either Bermuda grass or bent grass, we tend to see no relationship between soil test potassium and plant response. We don't see improvements in color, we don't see improvements in quality, and we don't see improvements in plant response to traffic or cold or any drought. We see very little benefits. We think that's because the soil is providing plenty of potassium. So potassium and phosphorus are two nutrients that when you get your soil tests, you could consider perhaps applying less than recommended, because right now we don't see a lot of response to adding potassium particularly. All right, now I'm ready for questions because I have 20 after, and to see if anybody has questions on things. If you want these presentations, I can email it to you as well.
Hi, Beth. Thank you very much. Hi again. These files are in PDF in this session.
Great.
Go to our next session. So anyone that may be interested in download these documents are ready for them.
And and you can give them my email if anybody wants to talk to me or email me. That's not a problem.
Yes, of course. So I will share with the chat as well.
Terrific.
Okay. Right now we only just have a question.
Mm-hmm.
Is about the effect of nitrogen to ryegrass tillering.
Yes, that's a great question. Yes, ryegrass is quite sensitive to nitrogen. It will respond, and it will tiller in response to extra nitrogen. I cannot give you exact rates. I'll usually start with about 2.5 grams of N per square meter when I seed my ryegrass, and then I'll add some as needed.
Okay. Okay. So, well, we don't have more
let me,
questions.
the other
If
answer
you,
for the,
we have 10 minutes more if you want.
no, I think we're good. And I forgot with the ryegrass, the other thing is ryegrass is very unusual, as you guys know, because it doesn't have rhizomes or stolons. It only tillers. So we call it a bunch type grass. So it really needs a good seeding rate and that nitrogen so that you get uniformity across your stand.
Okay. Beth?
Mm-hmm.
Okay.
Okay.
Perfect. Okay. So, well, for sure it's clear the answer.
Okay.
Okay. Then, if nobody has more questions,
We'll let them
well,
go home for you.
now there is a question.
Uh-huh.
Let me, because it's written in Spanish. Let me translate for you. Uh, which would be the rate, the theoretical rate for week of nitrogen, phosphorus, and potassium for greens of Bermuda grass, a hybrid Bermuda grass?
The rate for greens of hybrid Bermuda grass. Um, You know, a lot of our superintendents are, in general, we need at least 4.9 grams of nitrogen per square meter per month to keep a hybrid Bermuda grass green going well, from which you are removing clippings. We have some superintendents who will do 0.5 grams of nitrogen per meter square per week. So from 0.4 to 0.5, and sometimes that will be a little heavy as the Bermuda starts to go dormant. But our research has shown you do need that much nitrogen on a sand-based green to let the Bermuda grass grow and heal from ball marks and traffic. Some people will say I am too high, but my experience has been over time you need that. You could try like 0.3 grams, and if it doesn't grow well, you can add a little more, and then you do have to top dress to manage any thatch.
Okay, perfect. Another question.
Mm-hmm.
Superintendent asked that in his golf course there is Paspalum seashore, and they fertilize in spring and autumn, and then in
Uh-huh.
winter they have annual bluegrass.
Uh-huh.
So he asked, sorry. Well, okay, he said that in October there is the transition between Paspalum and Poa and annual bluegrass. So he's asking if it's good or not the fertilization in this season. I understand that late October.
Right. So he wants to fertilize the annual bluegrass to keep it around. Is that correct?
Well, maybe I think that
Okay.
he looks like he's interested in annual bluegrass in winter.
Okay.
So
Um, we did some work with Poa trivialis and Bermuda, not quite the same, but we did see that the cool season grass responded to light rates of nitrogen through the winter, like 0.1 grams. I think we did that monthly. It was fairly low rates, zero point 0.1 to zero point 0.2 grams of N per square meter per month. Seashore paspalum does not seem to need as much nitrogen as Bermuda. It's a little less, it does not respond as well.
okay, okay, perfect. Another question. We have several
Uh-huh.
questions.
Sure.
So uh, let me, because is can you confuse a bed fertilized soil between nitrogen or too much iron?
Oh, okay. So yes, iron is quite nice for making green color without growing things. So for instance, in the United States, as we go into fall in dormancy, we will see people using various iron compounds for color. But you do have to watch the rates. There are some people right now advocating very high rates of nitrogen, like I think 5 to 10 pounds for POA control. There's been some discussion of this, high rates of nitrogen. But there's now new work coming out of Wisconsin that's showing you can actually cement the putting greens. The iron will move through the green to the bottom of the green, and it actually makes a layer and water will not go through. So I like iron for color, but watch the rates and know that the color response is usually 7 to 10 days. And we don't see much difference due to source. So iron chelate, iron sulfate, there's some new iron glucoheptanates. We haven't seen a lot of differences.
Okay, more questions. How should be the fertilization on cool weather and golf courses and with cool weather and high the mountains? I assume.
Yeah. So there was a really nice study done recently that looked at cool weather fertilization for cool season grasses. So they looked at annual bluegrass, Kentucky bluegrass, and bentgrass. And what they found was, and I'll have to use American, I'm sorry, they found that they fertilized in September, October, or November. And those dates, I think it was like 60-degree Fahrenheit, 50-degree Fahrenheit, and 40. So really kind of mild and then cold. And when they fertilized in the coldest situation, which was like November, it did nothing. The grass did not respond, it did not grow. The September and October fertilizations were beneficial.
Okay, more questions. Would you be agree on using edaphic soil breathing as a way for measuring the soil community? I had results of 0.20 milligrams carbon of CO2 per kilo per hour for my greens. Is it okay?
Yes, I think I read that paper. Yes, we CO2 evolution is a wonderful measure of what your carbon community, what your microorganisms are doing. It is the way we measure a lot, and it's a very nice way to see what's going on. And again, anything you do like adding a carbon source or things like aerifying will often stimulate CO2 activity. And what you'll often find is it will go up rapidly, I mean like within an hour or two, and stay that way for a few days, and then it will start to go back down.
Okay, the same superintendent is saying that there are study research that say humus increase soil microorganism community in soil in short term. Do you agree?
Well, there are a couple. There's a really good paper. It shows it like within a month or two, like when you build a brand new green, but then it goes away. The interesting thing is we don't really have any data that looks at, say, like after the first 6 months, and then yearly until you get to things like the 15-year-old paper I showed you. There's another set of papers from Pinehurst in North Carolina that show no differences between golf course fairways from 1 year to 20 years old. And then once the golf course fairways get really old, significant increases in organic carbon.
Okay, more questions. Superintendent says that, that you say that organic fertilizers are beneficial for turf grass.
Mm-hmm. Are what for turf grass?
And he asks which is the way, which rates would be the the best?
Oh, organic. You know, that's a great question because, and I am a huge fan of organic fertilizers. I think they're a great way to get rid of a waste product. And because we don't eat turf, you know, we eliminate some of the health concerns that might happen if we apply these products to, say, vegetables. So typically, you can apply a higher rate because you'll have about 40 to 50% of that fertilizer mineralized or made available to the turf grass in the first year. So over time, you'll start to see some of that, more of the organic nitrogen become converted and available to the plant.
Okay, perfect. Then, well, the same superintendent talking about the use of organic fertilizers for improving the microbial communities, says that I have also seen a relationship between CO2 and lowering pH.
Yes, absolutely.
Yes, there is a relationship.
Yeah, it makes weak organic acids that then lower the pH. Yeah, and your roots do that naturally. Your roots and your organisms. That's why most soils tend to have a drop in pH over time. If you manage a soil that's on the acid side, the combination of natural organic acids and any fertilizer that contains ammonium is acid forming, those all will drop the pH over time.
Okay, Beth, then that's all.
Okay.
No more questions for you.
Those were great questions.
Okay, so thank you very much for your collaboration, for your interest, and that's all for me.
Okay.
I'm gonna speak in Spanish to say goodbye to the audience.
Say goodbye. Well, I've got to go. I just realized I have to go teach a class in 20 minutes, so I will see you guys. Okay. Thank you.
So thank you very much, Beth.
Bye.
Bye.